Welcome, ladies and gentlemen, to this video lecture. So now we move on to the integral mean value theorem. And before we can discuss the integral mean value theorem, we need to make a definition. So we will define what we mean by the average value that a function takes on an interval. So take any function f on an interval ab, as long as it is integrable, and we define the average value of this function as follows. So it is the integral from a to b of our function, and we divide by the length of the interval, and this value we then call the average value of f on the interval ab. Okay, so let us just give a short motivation of why this definition makes sense. Motivation. So why does this make sense? So let's just think about it. So we've got an interval ab, and we've got some function f. So here we've got the graph of f, and let us think what happens if we sample this function at n equal intervals. So we divide this interval into n parts, and let us define delta x to be the length of each one of these little intervals. So let us define delta x as b minus a over n. And let us define so this point here as x0, this point as x1, x2, x3, x4, etc. So xj we define as a plus j times delta x, where j is any number in from 0 to n minus 1. Okay, and now let's think about the average of the function values. F of x0 plus f, no, not plus, the average of all these function values, x1, etc., up to f x n minus 1. So what is the average? Of course, that is we are adding up all these function values, so from 0 to n minus 1, f x j. Okay, but there's a relationship between n and delta x. So we see here, if we manipulate this equality a little bit, we see that we can write n in terms of delta x. And what does that become? That becomes delta x over b minus a, sum from j from 0 to n minus 1, f of x j. Okay, and let us take this delta x in and see what happens. So this is something that you should recognize, this term. So this is the Riemann sum. That approximates, or this is a Riemann sum that approximates the integral, that approximates the integral from a to b of f of x dx. So this is roughly equal to 1 over b minus a of the integral from a to b of f of x dx. And of course, the more subdivisions you make, the closer your integral will, or the closer your Riemann sum will get to this integral. So we see here that if we sample the function values at regular intervals and we work out the average, we get something that approximates this integral. So now we forget that we come from there, and we define the average value of f over the interval AB as this value. So that is just a short motivation of why we define the average value of f over an interval AB like we do. Okay, I will see you in the next one.